8004. The opposition offered by a coil to the flow of alternating current, ignoring resistance, is called A. Impedance, B. Reluctance, C. Inductive reactance. The correct answer is C. Inductive reactance is the opposition offered by an inductor, coil, to the flow of AC current, ignoring the resistance of the coil. It is caused by the back EMF, electromotive force, generated in the coil as a result of the changing current. The back EMF opposes the flow of current and reduces the current flow, resulting in inductive reactance. Impedance is the total opposition to the flow of current in an AC circuit, including both resistance and reactance, while reluctance is the opposition offered by a magnetic circuit to the establishment of a magnetic field, similar to resistance in an electric circuit. 8004-1. What factors strengthen a coil inductor? A. Limiting and separating the coils. B. Adding and separating the coils. C. Adding coils close together. The correct answer is C. The strength of an inductor, coil, is determined by several factors, including the number of turns of wire in the coil, the diameter of the coil, the material of the core, and the proximity of the coils. Adding coils close together, or increasing the number of turns in the coil, increases the magnetic field strength and hence the inductance of the coil. Limiting or separating the coils can have the opposite effect and reduce the inductance. Therefore, option A is not correct. Similarly, adding and separating the coils may not necessarily strengthen the coil, depending on the specific configuration. 8005. An increase in which of the following factors will cause an increase in the inductive reactance of a circuit? A. Inductance and frequency. B. Resistance and voltage. C. Resistance and capacitive reactance. The correct answer is A. The inductive reactance of a circuit is directly proportional to the inductance of the inductor and the frequency of the AC current flowing through the inductor. In other words, an increase in either the inductance or the frequency of the current will result in an increase in the inductive reactance. Resistance and voltage do not directly affect inductive reactance, although they may affect the overall impedance of the circuit. Capacitive reactance, on the other hand, is caused by the presence of a capacitor in the circuit and is inversely proportional to the frequency of the current. 8006-1. Capacitors are sometimes used in DC circuits to A. Counteract inductive reactance at specific locations. B. Smooth out slight pulsations in current divided by voltage. C. Assist in stepping voltage and current up and divided by or down. The correct answer is B. Capacitors are commonly used in DC circuits to filter out or smooth out small variations or fluctuations in voltage or current, which are also known as ripple. When a capacitor is connected across a DC power supply, it charges up to the supply voltage and then discharges when the voltage drops below a certain threshold. This process helps to even out the fluctuations in the voltage or current, resulting in a smoother and more constant output. Capacitors can also be used in AC circuits to counteract inductive reactance at specific frequencies, as in the case of a tuned circuit or filter. However, this is not typically done in DC circuits. Capacitors are not typically used to step up or step down voltage or current, as this is the function of a transformer. 8007. In an AC circuit, the effective voltage is A. Equal to the maximum instantaneous voltage. B. Greater than the maximum instantaneous voltage. C. Less than the maximum instantaneous voltage. The correct answer is C. The effective voltage in an AC circuit, also known as the root mean square, RMS, voltage, is neither equal to nor greater than the maximum instantaneous voltage.